Hello dear friends, welcome once again to PDV Leadex Education. It is another wonderful session with organic chemistry. So we are going to answer this extract from Cameroon GCE Advanced Level Chemistry. So the question says that study the reaction sequence below. Study the reaction sequence below. Roman 1. Name the compounds C and D. Name the compounds C and D. This is compound A, compound B, compound C, and compound D. Okay, so we are going to analyze a synthetic route, right? This is synthetic route. And when you are answering synthetic routes, the first thing that you do is that you try to identify the various compounds involved. This is a very special synthetic route as far as organic synthesis is concerned. So you are supposed to master this synthetic route and know every detail about it, right? That is reaction condition, reagents, as well as methods of separation. Okay, so here we have benzene, right? We have nitrobenzene. We have benzene, nitrobenzene. This one we call it phenylamine, right? This is an amine group. This is a phenyl, so this is phenylamine, or you call it aniline. This is benzene diazonium chloride. We call this compound benzene diazonium chloride. This is the diazonium group N2 plus Cl, right? You call it a diazonium group. This is a very a rapidly living group, as we shall see. Okay, so there we have named the compounds benzene, nitrobenzene, phenylamine, and benzene diazonium chloride. Then state the reagents and conditions for the steps 1 to 3, right? So step 1, how do we prepare nitrobenzene from benzene? We use a reaction mixture called a nitrating mixture. So the reagent, concentrated nitric acid, concentrated sulfuric acid, right? Concentrated nitric acid and concentrated sulfuric acid. Condition 55 to 60 degrees Celsius under reflux. Under reflux, because benzene is highly flammable and highly volatile. So the reaction will be carried out under reflux. Next, step Roman 2, nitrobenzene to aniline, right? What we use there, we use the process, right? This process for step 1 is called nitration. This process, you call it nitration. Now, from nitrobenzene to aniline, the process is called reduction. Reduction. And what happens is that the oxygen atoms are replaced by nitrogen. So reagent here is tin, right? Tin in concentrated hydrochloric acid. Condition, you are going to heat. So that's the reagent. Tin or iron, right? You can also use iron. Tin or iron, which is a reducing agent in concentrated hydrochloric acid, and condition, you heat. The process is called reduction, and the formula of the product is obtained by just replacing the oxygen with nitrogen. Now, the last reaction, phenylamine to aniline, right? Phenylamine to aniline. The process is called diazotization. Right? This process, you call it diazotization. And the reagent for this process is nitrous acid. Nitrous acid is NO2, right? But nitrous acid is a very poisonous acid. So we are going to prepare it in situ. We prepare it in the reaction mixture using what? We are going to use sodium nitrite, right? So we shall use sodium nitrite and concentrated HCl, right? Sodium nitrite and concentrated HCl, that is the reagent. These two, they are going to react in situ to produce nitrous acid. Then the condition is 0 to 5 degrees Celsius. That is the reaction condition. Why? Because the diazonium salt is very unstable. So we carry out the reaction at low temperatures due to the high instability of the diazonium salt. As I earlier said, the diazonium group is a quick or a fast living group. So it is very unstable and can easily dissociate if temperatures are not maintained or regulated. The process is called diazotization. Now, next question says that outline the mechanism for the conversion of benzene to nitrobenzene. Mechanism to convert benzene to nitrobenzene. Right, that process, that the mechanism or the reaction takes place by electrophilic substitution. So, electrophilic substitution. Let's write the mechanism of the nitration of benzene. So, what happens is that first we are going to show how the electrophile is formed. The electrophile here is the nitronium ion, right? NO2 plus. So as we said, nitric acid is going to react with sulfuric acid to form our main compound, or the main product is a electrophile. Then it will also form hydrogen sulfate, and it will form the hydrozonium ion, right? We balance the equation. Well, you balance the equation, right? Next, the nitronium ion is going to attack, right? This is our electrophile. It will attack the benzene ring. So the benzene ring has 6 pi electrons which are delocalized in the system. The diazonium ion will attack the benzene ring, and benzene is going to donate 2 of the pi electrons to the hungry nitronium ion. When benzene does that, the two are going to form an intermediate that we call a Whelan intermediate, right? And the nitronium ion is going to destabilize hydrogen at the position. So from there, the hydrogen is going to be very angry, and as a result, the benzene will try to restore the ring by pulling away or seizing the 2 electrons that it shares with nitrogen. The hydrogen sulfate, this one, right, is going to come to rescue the nitrogen while enabling it to allow the sigma electrons to benzene. When that happens, we have finally the hydrogen is going to leave and nitrobenzene is going to form, while sulfuric acid will be regenerated. So that is a mechanism for the nitration of benzene. The process takes place by electrophilic substitution. Next question. What method can be used to obtain pure phenylamine from the solution? Right? How do we obtain pure phenylamine from the mixture? Take care. Phenylamine has been prepared from nitrobenzene. That means that the mixture contains phenylamine and some nitrobenzene. So how do we obtain pure phenylamine, right? Now, we can go by fractional distillation, because phenylamine has lone pairs. Phenylamine has lone pairs on nitrogen, and as a result, phenylamine, right, will be able to form hydrogen bonds. Hydrogen bonds are formed when hydrogen is bonded to a highly electronegative element. Like here, hydrogen bonds are formed under 2 conditions. First condition, hydrogen must be bonded to a highly electronegative element. And here, hydrogen is bonded to nitrogen. In chemistry, there are three particular highly electronegative elements. And those ones, they are the halogens, oxygen, and nitrogen. Those are the 3 most important electronegative elements in chemistry. So here, hydrogen is bonded to nitrogen. So the first condition for hydrogen bonding is satisfied. Next condition, the highly electronegative element must possess what? Lone pair of electron. And clearly, there are lone pairs on nitrogen. So it therefore means that phenylamine possesses hydrogen bonding. And as a result, phenylamine has a very high boiling point compared to nitrobenzene, which only has van der Waals forces. So as a result, the two components have a great difference in their boiling point and can be separated by fractional distillation. But the best answer here will not be fractional distillation, because this process is more applicable industrially on large scale. And on large scale, the objective is to maximize purity of the compounds, and as a result, to maximize purity and efficiency, the best method that will be used is called steam distillation. Steam distillation. Why? Steam distillation is used whenever there is a component in the mixture which can form hydrogen bond with water. Right, so phenylamine, steam is going to be passed through the mixture of phenylamine and nitrobenzene. Phenylamine will form hydrogen bond with the water or with the steam and will be evaporated over, then condensed and separated, while nitrobenzene will be left behind. That is the best method to separate phenylamine from nitrobenzene. Next question, give the structure of the compound's form when benzene diazonium chloride reacts with A, copper cyanide and potassium cyanide. So if benzene diazonium chloride, right, which is this, if benzene diazonium chloride reacts with, right, well, I'm going to wipe a bit, right. I hope you have written all this. So our benzene diazonium chloride, this is benzene diazonium chloride, right? To write the full structure, the positive charge is found on the carbon, on the nitrogen atom that is bonded to the benzene ring. So here we normally have a triple bond, right? And then we have nitrogen. The nitrogen bonded to the ring has a positive charge, while the terminal nitrogen has its lone pair of electron. Then we have the chloride ion, right? That is the structure of benzene diazonium chloride. So you notice that this nitrogen, no, here we have 6, 8. Yes, right, our structure is okay. So here you notice that now when benzene diazonium chloride goes in reaction, right, it goes in reaction as an electrophile. So the chloride ion, right, is going to be displaced from the reaction mixture. The chloride ion will circulate in the reaction mixture, while the diazonium ion will play the role of an electrophile. So this diazonium ion is actually an electrophile. So if I put my chloride ion, we are asked to write the product of the reaction when benzene diazonium chloride reacts with what? Copper cyanide and potassium cyanide at room temperature. And also the product when it reacts with naphthol, right? When it reacts with naphthol, this is naphthol. This is the structure of naphthol given to us. Yes, we are asked to write the product of the reaction when benzene diazonium chloride reacts with copper cyanide and potassium cyanide. The product there is simply so the diazonium group will be replaced by cyanide, and the compound form is called cyanobenzene. So the cyanide is going to replace the diazonium group. Take care, as I earlier mentioned, the diazonium group is a very rapidly leaving group. So it will leave the aromatic ring and will be replaced by the cyanide. That is a product, and the other product is called cyanobenzene, right? Cyanobenzene. Now, when benzene diazonoyl chloride reacts with what? Naphthol, right? Naphthol. The reaction is called a coupling reaction. A coupling reaction, and the product form is called an azodide, right? It produces azodide in what we call a coupling reaction. So in those reactions, the diazonium ion will play the role of an electrophile. So the reaction takes place by electrophilic substitution, right? The aromatic ring is activated because on naphthol there are lone pairs on oxygen. The lone pairs are going to activate the aromatic ring by positive mesomeric effect. The lone pairs will be donated to the aromatic ring and the ring will be activated. That therefore means that the hydroxy group will substitute, right? The hydroxy group will direct the incoming electrophile. The electrophile is without the chloride. So this diazonium ion will attack naphthol as an electrophile and will undergo electrophilic substitution. The hydroxy group, which activates the ring by positive mesomeric effect, is going to undergo an auto-para directing. So it will direct the diazonium ion to the auto and para position. So where is the auto position? Auto is number 2 and para is number 4. So this is 1 here. This is 2, right? This is also 2, and this is 3. Then this is 4, right? If you notice well, you see that the carbon number 4 is already occupied by the other aromatic ring. So the only possibility here is the auto position, which is free. So the diazonium ion will substitute on the aromatic ring, right? On the first aromatic ring, the one that has the hydroxy group, it will substitute there at the auto position, since the para position is already occupied. So what do we have? We are going to have this, right? So we are going to have we draw first our naphthol, right? You can draw it anyhow. You can begin with the diazonium ion first. So this is your naphthol, right? So let's undergo the substitution here at this para position. So there, right, there, hydrogen which is here, is going to be removed by what? By the chloride which was here, right? So here we shall have a new bond is going to form between carbon and this nitrogen. So they will form a bond. Then the triple bond, right? While there's bond formation, one of the pi electron in the triple bond will migrate to occupy the vacant orbital on nitrogen. So the nitrogen will now possess its lone pair, and this one, right, already had its lone pair. Then from there we shall have the aromatic ring, right? We shall have our aromatic ring for the diazonium ion. So that is the structure of the compound form, and that compound is called an azodide. The reaction is called a coupling reaction because two large molecules combine to form a smaller one. So they form a couple, somehow a couple, and we call it a coupling reaction. So please, your assignment, right, or your exercise is that you should write down the mechanism for the coupling reaction of what? Benzene diazonium chloride and naphthol. Write the mechanism for the coupling reaction of benzene diazonium chloride and naphthol to form the azodide, right? The reaction takes place by electrophilic substitution. So you put your answers in the comment section and we are going to follow up with you. That brings us to the end of this session. I believe that you understood a lot. So please like the video, share, and tell your friends about the educational biome of pure excellence, PDV Leadex Education. Share the video as much as you can and promote PDV Leadex Education wheresoever you find yourself. Thank you so much and may God bless you. Bye-bye.